Electricity is one of the greatest innovations ever made. And though there was a time that humans lived without this commodity, it is hardly possible to imagine how the world would operate today without this precious commodity. The production of electricity is generated in power stations that are far away from the load. That is why there are extensive conductors that are set between power stations and the needed consumers. Due to this fact, power loss in transmission lines is a common issue. The article will address power loss and how to reduce it. Different power is lost at different stages. 1 to 2% of energy is lost during the step-up transformer from when the electricity is generated to when it is transmitted. 2 to 4% of energy is lost in the transmission lines. 1 to 2% of energy is lost during the step-down of the transform from the transmission line to distribution. For 6% of energy is lost during the distribution, so the average loss of power between the power plant and consumers ranges between 8 to 15%. In modern society, we cannot think to live without electrical power. In early days, electricity was transmitted by using direct current. After Nicholas Tesla invented alternating current 1886, this electrical transmission gets much popular. Today we can send power through the continent by using this alternating current. Once the length of the transmission line becomes longer, the conductor resistance also gets the increase, so the energy loss is also getting increased. This problem of the AC transmission is much solved by using transformers to step up voltages. But there is another problem that occurs due to the impedance of the transmission line. Another external property called reactance also happen in this transmission lines, and this lead loss in the front too. This happens mainly due to the property of inductance and the capacitance of the transmission line. Inductors have commonly resisted the changing in current, and temporarily storing energy in the magnetic field. The capacitor is also opposed to the voltage differences and temporarily storing energy in the electric field. Transmission line losses are a major concern in electrical engineering, especially when it comes to efficiently distributing power from generation plants to consumers. These losses affect not only the overall efficiency of power systems but also the cost and reliability of electricity supply. Understanding the causes and mitigation strategies for these losses is crucial for electrical engineers and industry professionals. So, what are transmission line losses? Any power transmission system incurs losses because some power input is dissipated as heat. In AC transmission, the main culprits are the line's resistance, reactance due to inductance and capacitance, and corona discharge. These losses, known as transmission line losses, can range from 5 to 10% over long distances if not properly managed.